A baseball is thrown at a 30-degree angle from the top of a 15-meter cliff. What is the range of the throw if the initial velocity is 28 meters per second? Before we start, this one's going to be a little bit trickier than the other ones, so buckle up. So if I sketch this thing out, we've got the baseball thrown at 28 meters per second from the top of the cliff, which is 15 meters. And it's at a 30-degree angle, and as you know, it makes this parabolic path. But this one's a little different because it was launched at an angle and it was on top of a cliff. The math's going to be a little bit harder. Our first step is going to be to break this velocity apart because it's at a 30-degree angle and we don't like angles. So let's find Vx and Vy. When I run sine and cosine on this angle, I get 14 and 24 for the two components. And by the way, I've been rounding these numbers off a little bit. That's just to make the videos easier to follow. But if you want to leave some decimals in there as you work the problems to get more exact answers, that's fine with me. I've just been doing them to make it easier to see what I'm doing. Anyway, for a 30-degree shot, you're shooting it more to the right than you are up, which means when I look at these two numbers, I know the 24 is going to be Vx and 14 Vy. So setting everything up and plugging in the values we already know, I get this. And remember, the most important part of the problem is time. And we have a lot more information in the y direction, so we're going to begin there. As usual, when we're solving for time, I'm going to go with delta y equals 1/2 at squared plus vit. However, the initial velocity was not 0 this time, and on the previous videos we used the peak trick. We just simply waited until we calculated the amount of time until there was no velocity left, which would be easy here. It would be 1.4 seconds, but unfortunately, since we started on top of a cliff, these two times are not equal. The object actually spent more time going down than going up. So we have a bit of a problem. We've got something being shot at an angle, but we can't use the peak trick here, unfortunately. When I set this thing up, there's only one way to finish the problem off, and that's using the quadratic formula. This is actually going to take a little bit of work, so I'm going to have to jump to a new page to finish this off. Now, before you can run the quadratic formula, you got to set equal to 0. So this is my expression, and we're trying to find a value for t that makes this true. Now, in case you've forgotten, the quadratic formula is minus b plus or minus square root b squared minus 4ac divided by 2a. And what it means by the a, b, and c and all that is a is the number that goes in front of the t squared, b is the number in front of the t, and c is what I call the naked number. It doesn't have a t to go along with it. So let's plug it in and solve this thing. So after throwing all the values in, I get this, and then simplifying, I get this. Now be careful over here because there's a negative outside of the parentheses, and there's also a negative on the 5, so those end up getting added. If you ever get a negative number in the square root, it means you made a mistake with your negatives somewhere, so go back to the original problem and check all your values. Anyway, solving for t, we get t equals either minus 0.83 or positive 3.63. Of course, since this is physics class, a negative time isn't going to make a whole lot of sense, so we're going to reject the first solution and accept the second one and use this in the problem. Whew, glad that's over. Well, now we finally figured out that time was 3.63 seconds, which means we're ready to go to the x side of the problem. I promise you this column's not going to take as long as that one did. Great, so we know that it's in the air for 3.63 seconds, and we also know that in the x direction, it's flying 24 meters every second. So finally, if you go 24 meters to the right every second, and you do that for 3.63 seconds, then you get a horizontal range on the shot of 87 meters.